Hello and welcome back to Dr. Logic Awkwardly Does Logic. I swear I didn't intend to leave you in the lurch for so long, but we are back and we are going to move on from talking about system S4 to the next system in line, which is system S5. Now, S4 was constructed by adding a reduction principle to system T. We picked the weaker of the one that said that necessarily P implies necessarily P. In system 5, we're going to add the stronger one. So this means that we will be able to prove more things. In fact, we'll be able to prove everything that we could have had in S4 in our new system. And that's why S5 is going to be an extension of S4. So let me get up my whiteboard so that we can see all of the details about this. So the construction of S4 was by adding this reduction principle, necessary P implies necessarily P, to system T. S5 is going to be by adding possibly P implies necessarily possibly P. And we're also going to just add this to the base system T. Now, this particular axiom is itself sometimes called E. So one definition of S5 is T plus the axiom E. Now we are going to come about to see another definition of S5, which is really interesting because it shows kind of modularly how it is related to S4. But for now, we're going to look at this as the motivation. So we had two reduction principles. We took the weak one, added it to T and got system S4. Now we're taking the stronger one, adding it to T, and we get S5. Because this is stronger, it means that we're going to have all of the same reduction laws that we had in S4, but we are also going to have new, stronger ones. In fact, the 4 reduction laws in S5 are these. We have that necessarily P is equivalent to necessarily P, that possibly P is equivalent to possibly P, that possibly P is equivalent to necessarily possibly P, and that necessarily P is equivalent to possibly necessarily P. So what you can see with each of these laws is that on the one side, we've got one modality. On the other side, we have two modalities. But the first one, the one on the left, as you're reading across, doesn't matter. So you can always go from some collection of two and reduce yourself down to just the one that is closest to the atom. So we've got a box here, and a box here, and a diamond here, and a diamond here, and a diamond here, and a diamond here, and a box here, and a box here. So essentially what S5 says is that iterated modalities don't make any difference. You can always collapse down to just a single modality. So some of these are definitely in need of proof. Let's take a look at, let's do this one. This one looks interesting. How can we prove this with the addition of this new axiom that we have? Well, one thing that we can see is that this axiom is half of the equivalence. So our first part of the proof is just going to be to write down that possibly P implies necessarily possibly P, and this is justified through our new axiom E. Now, because all of this is built on system T, we can use the T axiom. In fact, we can get to the other direction by saying that necessarily possibly P implies possibly P. This is a substitution instance of the T axiom where I've just put possibly P in for P. And then propositional logic allows us to put the two of these together. So propositional logic, lines 1 and 2, if P implies Q and Q implies P, then P and Q are equivalent. And then, of course, once you have this, deriving this one is going to be very easy. You can just do it through contraposition. substitution with negations, some double negation. It's a very similar process that we have seen before. So there we have it. S5 is really incredibly simple and incredibly powerful. I'll leave it here for now, just to give you the basic definition in terms of this new axiom, this reduction law that we are going to add to system T. But next time, I will make good on my promise to show you another way that we can axiomatize S5, which turns out to be equivalent. And we can prove that they're equivalent from whatever set of axioms we take. We can always prove the other ones and vice versa. And then after that, we can start doing some really fun things with S5. It has so many beautiful properties because you don't have to worry about the complexities of all of the modalities. You can just reduce down to one single modality, and this will allow us to do some really excellent stuff when it comes to proving completeness. In any case, join me then. I hope to see you again soon. Cheers.